Our next presenter is Ken Salenza. Did I get that right? Excellent. He'll be presenting next generation firewall automation. Ken is the VP of Professional Services at Network to Code, and this is his first time. We are certainly very happy to have you here today.
So, as previously alluded to, I'm Ken Salenza, VP of Professional Services at a company called Network to Code, specialized in network automation. I've been involved in dozens of projects with network automation over the last half decade or so. I was your traditional network engineer by day, coder by night throughout my career. I converted to full-time network automator in 2016 when I came to Network to Code. I've been in the industry over 20 years, primarily supporting enterprises for the Air Force, McKinsey, and Network to Code, of course. Okay. Oh. That was not what I was supposed to do. Okay, I think I got it now. Apologies. Okay, so quick agenda. We're going to go through manual firewall rules, management, how it currently happens for most organizations, and talk about what I'm coining as current generation firewall rule automation, and then what I'm coining as next generation firewall automation. And then we're going to do a demo. It's going to be a little bit of a different demo because there is no cable here, so I pre-recorded it. I'm going to be talking to it live, so bear with me if my timing is slightly off. Okay, so manual firewall rule management. This is kind of what I see for most organizations as we get integrated to potentially talk to them about automating such processes. We'll see a workflow. We see a workflow something like this, which is basically a user makes a request, oftentimes an Excel document or similar. Some security person reviews it for validity, whether it's a good rule or not, what path analysis, what type of which firewalls it should go on, potentially multiple firewalls. Go through a CAB review process to schedule that change. And then finally, of course, implementation and closing on the ticket. Again, very simple, but just want to kind of reset ourselves here overall. Okay. So when I work with our customers, this is kind of generally speaking what we do is talk about this next step, which is current firewall automation. I am getting some signal here. Oh, wow. Okay, I did not realize there was a button. My apologies, folks. Sorry for driving you guys crazy. Okay. Egg on my face, that one. Oh, so now I need to go back. Okay, sorry about that, folks. All right, so current firewall automation. This is what I kind of typically work with the customers on. And we start developing a workflow similar to this. I kind of highlighted here which parts of the workflow will be automated versus not automated. So standard, user makes a request into an ITSM tool, oftentimes ServiceNow or something similar. The operator still goes through, reviews that process. Then we get into some of the steps that can more often be automated. Some of that pre-validation steps. Do things like the security review, the security review to say what's a good rule if it can be programmatically detected, as an example. Do things like that path analysis. Oftentimes things like an automated trace route, as an example, or an IPM lookup. Okay, goes to that standard CAB review process, and then go through pre-checks. Most common pre-check, I'll kind of talk about the Palo Alto world, which is to do that test policy command to see if, in fact, pre-change that the policy or the traffic is not allowed, so that we can verify in the post-check that it is allowed. All right. You, of course, deploy the configuration, which is obviously a big part of any automation, and do that post-check, which is the flip side to those pre-checks that happens. And, of course, close out the ticket. Okay, so there are a lot of benefits for this, and I wouldn't dissuade anyone from going this route. We're going to talk about the other side of this as well. But so first and foremost, to standardize and normalize your configurations. I always say that I may use dashes and Joe is going to use underscores. It makes it hard to parse the configurations later. You get that form validation to ensure a reasonable level of quality instead of those spreadsheets. So if someone's using an ITSM tool, there's actual form validation to say it's an IP address or an IP range, etc. Enables customers to self-provision, which helps reduce time to market, right? If they are a technical savvy customer, they can create that request and see the automation go through without potentially any interaction themselves with the security team. Provides traceability of those configuration pushes. And we'll talk about what some of the traceability doesn't provide, but it does. You can go back and say, this one rule was deployed on this day for this reasons and so forth. And it reduces that monotonous task and associated fatigue. I work with some organizations where they are literally dealing with hundreds of firewall rule changes a day, and that's you're just gonna mess up at times there. There's no two ways about it. Okay, but we're gonna talk about next generation. So what's the problem statement here? What are some of the cons associated with this? It requires expert level knowledge on how applications and networks work. We as network engineers, security engineers, will oftentimes not really remember what it was like to not know these things, but I've heard from hundreds of application developers not understand the idea of bidirectional traffic and where the TCP send is being sent, thinking because information is going to and fro that it should be bidirectional. But obviously, we as network engineers know that's not the case. It is not an intended state. It doesn't provide the intended state source of truth infrastructure. Can't get that declarative configuration as an example. Okay. Rule creation is difficult to track here, right? So when you have to view a rule, you can find that one rule. If you want to view all rules, it's very difficult to go back and understand who did what when. Basically, it's just a long audit process. Similarly, rule ownership is hard to understand. Who owns that rule, right? Especially when you have shared objects and similar things. Traversing multiple security points just kind of complicates things. Various different firewalls and different edge control components that are there. One of the things I've noted is that firewalls grow exponentially, but they're rarely removed. Okay, so now we're getting into the crux of it, next generation firewall automation. And this is what I'm going to say is around the idea of application-centric firewall automation. So it's a source of truth that models applications and the relationships between them. And that's the crux of what we're doing here, is data modeling around applications and then how they interact with each other. So application dictionary is a term I've been using for well over a decade. It's not an industry standard. I've not really heard anyone else talking about such an idea, so I just kind of created this. So if you go investigate, you're probably likely just to find other things I've done before. But nonetheless, without lack of an industry standard term, this is the term I'm going to go with. So this is what we want to do, is we want to allow businesses to speak in business terms, right? What are the applications what are the users looking to do? They want to say something like CRM API can talk to the CRM DB. Those are the terms they want to. Instead, what they have to do is from this specific IP to this specific IP on that specific port, right? You want to get away with that. That's very technical for the average user of these firewall rules and security posture and overall. There's a side benefit to assign metadata to application, and there's many different things you can do with that to understand your security posture much better, to understand things like confidentiality of data, who the owners are, encryption, etc. Manage non-firewall control points. And what I mean by that is we have AWS security groups, Firewall D, etc. And we'll talk about that a few more times throughout here. And how do we manage that? And the idea here is by modeling the infrastructure, not just modeling firewall rules, right? It's a change in kind of concepts there. Rule optimization to remove duplicate and unnecessary rules. And we're going through a specific example of how we're going to do this. But the idea here is if we have security enforcement happening in AWS security groups, why do I then need to have additional firewall rules to say exactly the same thing as those security groups are already providing? And provide full firewall rule configuration, often use the term declarative. The current generation is transactional in nature. Push configurations, and that data is for the most part gone and lost forever, right? You can go back to the ITSM tool or whatever tool that you put it in to find that information, but it's not readily available. It's not easy to track. It's hard to do so, and you can't rebuild the current state from that. Okay, so some of the complications of a modern network. No longer is source and destination IP and DNS the end-all be-all for what those source and destination objects can be. Instead, there's things like LDAP groups, container services, app ID, etc. SaaS services. NAT and VIPs. This is where users may not realize, or application owners may not realize that the IPs that their servers are on are not the IPs that their users are going to need, and to put the firewall rules to the VIP, not to their own actual devices. It's kind of hard for them to track that information. Okay, edge enforcement. Kind of talked about that before. There's multiple layers of security, and all having a duplication of efforts. Okay, so this is kind of the design around the application dictionary. It starts with defining applications. Things like CRMDB is this IP with this port, CRM API is this IP with this port, etc. Then defining the relationships between those applications, right? So I want my SMP server to reach out to my CRM application to manage it and kind of make sure that everything is monitored correctly. I want my CRM application to reach out to LDAP service, as an example. You still go through that security review process as you would in any kind of scenario to ensure that this is required. One of the interesting use cases that come with this is the idea of having the application owner into that process as well. To do things like, say, for my LDAP service, I don't need to do it, just let anyone can have access to it. But for my HR application, I want to know who is accessing my data, my database, and I want to be part of that security process. And since we know who the application owner is, we can embed them into it. And then, of course, the configuration management aspect of it, to actually deploy the configuration. Okay, so we'll take an example from the previous slide and show how we do this. And we're going to take the access request, the source and destination, and combine it with the application definitions to show how we get to this 5-tuple firewall rule configuration that we're all used to. Right, so we can mind map how we translate from the source IP and destination IP ports to build out that firewall rule. In this demonstration, just kind of quickly review the automation stack. So we're using Nonobot as the open source truth automation platform. Application dictionary, which is a plugin, primary objective of what we're talking about. We have a separate plugin for a firewall model. It may seem a little bit counterintuitive, actually helps solve some interesting problems. And then using Kapirka, I believe that's how you pronounce it. I never heard anyone else say it before. And what this does is model from a policy and service terminology that Kapirka uses to the vendor specific. Specifically using Palo, but it can translate to GNOS, XR, ASAs, etc. And then finally use Nornir to deploy the configurations. Okay, so the workflow for this is user makes a request. That request can be adding an application, adding to an existing application, or one of those relationships between those applications. There's an ETL process, ETL standing for extract, transform, and load. The key part of that is the transform part, right? And what that allows us to do is to have a point to apply business logic to optimize our rules, right? Then it gets to the firewall model, which does just that and models firewall rules. Kapirka generates configuration, and then finally Nornir is used to deploy those configuration to the edge device. Okay, demo time. Let's see how this goes here. What we're going to do here is we're going to add an application and deploy configuration. look at the application definition here. And we'll see that we're going to hone in on the HR application and talk about some of that metadata I was referring to before and how that relates. So we have simple things like description, but more importantly, things like who is the application owner, right? This is one of the things I find that organizations don't do well, is to understand who owns applications. Which components, specifically, which VMs are being used here in the Amsterdam data center. In this example, which services are applied here, meaning which TCP ports are used, what's the justification, what's the confidentiality level of that. And then from this view, we can see the relationships that are inbound and outbound from that application here, right? And we're going to specifically hone in on this LDAP here. And we're going to show how Jersey City Firewall cares about this application that really only exists in Amsterdam data center, right? Okay, so we look at the Jersey City Firewall, and we can start understanding how to mind map these applications. And specifically, we'll look at this first one from the HR to the LDAP service, the HR application existing in the Amsterdam office, having a destination Jersey City data center, right? But how does it relate that traffic to know to go to Jersey City Firewall? Because the Jersey City virtual machine, or the LDAP server in Jersey City, has an IP address in the 1030/50 range, and we defined a zone that has that network. So we're able to stitch together and dynamically build out that relationship on the fly to understand how applications are stitched together and the associated configurations that get deployed from them. Okay, great. So one of the interesting challenges I talked before about that ATL, that transform step here, and we're going to jump into that here. This transformation step, as I was building this out, I realized that the Atlanta firewall in this demo here has all the monitoring traffic. So it's a lot of source or destination, depending on if it's SNMP or syslog, used over and over and over again, right? So constantly going from monitoring to auth, CRM, all these different kind of components. It's a service used constantly, similar for syslog and LDAP. And so when we look at the Atlanta firewall here, we're going to see that we've defined all the application dictionary view of the world between the relationships between all of them. However, we have that transform step to understand business logic. And the business logic I applied here was to create address groups and group together these common services, such as SNMP, syslog, and LDAP, right? So we see over and over, same source IP, different destination IP, same source IP, destination IP for SNMP, the reverse true for syslog, and respectively for LDAP service as well. Okay, so we have this, 8, 9 times here, however many kind of rules are shown here on the application dictionary side of it. And then we're going to scroll down here in a second, which is going to show us the firewall rule model, which is very similar view, but you're going to see how the configurations are generated differently. And the model is different because of that business logic that we use in that transformation step here. Okay, great. So what we did was, rather than just copy the rules over, we said, insert that business logic and say, we'll just create a destination address group for the SNMP managed services or a source address group. And then we aggregate all those rules together. We're still tracking all that metadata, who's the rule owner, who put this in, when, why, etc. The configurations are an artifact of the data model. The firewall rules are not the data model in this scenario, right? And that fundamentally changes it. And this is just one use case, but there's many other use cases, such as I mentioned before, just ignoring rules, allowing things open from an IP level, because AWS is managing that security posture. So why create those duplicate firewalls? I know I'm quick here, but just want to show the firewall policy is being deployed. It is pretty much, it's the same configuration, the same 5 rules are applied on both sides of this scenario. So the Jersey City Firewall data model looks just like the actual configuration on the actual the Palo Alto firewall. Okay, so now we're going to jump into actually configuring an application, and specifically the dependencies. So we have the CRM application just being created, and we're going to build all those dependencies here. And that means connecting to the DB, connecting to LDAP, and then the monitoring services as well. Okay, so we'll show how we build these dependencies and how that actually gets deployed. I'm quickly creating the application dependencies here. Just note that it's happening. It's pretty quick, not too interesting, I would say. Okay, so now all the mappings are shown or built. We will go to the dependencies view of this table, and from there we're going to understand, and we will see the CRM application upon refresh start showing between all these application dependencies that are shown here. Okay, great, and then we'll see the CRM used multiple times, go into that, and we can see the inbound and outbound dependencies are dynamically built throughout the entire process. Okay, so now when we go back to the JRC firewall, which has the CRM application, we will immediately see the changes in the application dictionary, but not the firewall model. And the reason that is it goes back to that ETL process, that transformation step, that synchronization step. That's a second step, purposefully a second step that happens. So we have a job here to sync the databases. We will run that job, which will sync between the three different firewalls, excuse me, the three different firewalls, apologies, that are out there. And we could see that we've now added the CRM application to this series of steps. So the only thing left to really do here is to then push the configuration. That's what we're all here for, right? Actually pushing the configuration to the edge firewall. And we have another job there that's dedicated just for that, to push that configuration from the data model to the Palo Alto device. Okay? And I'm going to deploy it, jump back, show you what the firewall will look like before on the Palo side. You'll see that the last rule there is not a CRM rule. We'll see the Caprica configuration syntax. And then upon refresh, we'll see that all of the we'll see that the CRM firewall rule has now been added to there and is now in sync with the intended state source of truth here. Awesome. So that's the demonstration there. So I'll jump into kind of availability. I do want to stop here for 1 second and just say that I really want to evangelize the idea more than any kind of solution here. We're still building this out. This concept, I think, is needed in the industry more so than talking about a specific solution. I think building solution brings it to life, and that's why I really enjoy this. But I don't want to conflate the two there. Okay, so availability, Nodabot's open source currently. The Nodabot firewall model, which is going to be kind of underlining, is scheduled to be released this quarter. And then the application dictionary for next quarter to be open source. Okay, and that's it. Thanks. I've been talking about this a few times for other places, so here are some links to hear me talk about this at other places as well.
Do we have any questions from the audience? We got one question online here. This is from Gus. Gus says, how does NanoBot compare to the solutions such as TUFN's product?
Yeah.
Okay. Secure App 2, not much administrative work is needed to keep the information accurate in Nudabot. Does Nudabot offer any way to check roles being added to a firewall security policy?
Okay, yeah, so for Tufin and AlgoSec and Firemont, similar in that space, and they kind of understand mathematically how firewall rules are used. They're going to have better things for things like path analysis and so forth, but it's fundamentally a different solution, right? This is to data model applications, and that's to data model firewall rules, right? So it's fundamentally different. The next part was how much work is keep the information? A lot. That's the biggest drawback for sure. It is fundamentally, you require organizational commitment to do something like this, okay? But it gives you, there's a lot of side benefits for that. Any ability to check? Nothing specifically right out of the box, but the whole idea of the platform is similar to many other platforms, ServiceNow, Ansible, et cetera. It's more frameworky, meaning it's intended to allow for flexibility and expansion of other services to be built on top of it.
Our next question comes from Al. Can the NanoBot tool audit the firewall rules against its own data model in the case of manual rules introduced?
Yeah, I don't want to say it's not trivial. It's a bit of an ask. It goes back to the flexibility thing. It was definitely one of the things. It's such a use case I'd want to kind of deep dive and work on. The separation between these two models, between the application dictionary and the firewall model. Actually, one of the nice side benefits of that is the ability to have a transition period to go from one world to another, just traditional firewall rule management to this application-centric view of it. But definitely a use case I'm interested in as well.
We have one from the floor.
David Farmer, University of Minnesota. I got one minor detail. You have a nice application model. How do you get the application owners and the application creators to help you fill out that model instead of having to reverse engineer it?
It has to be a top-down approach. It fundamentally has to be a top-down approach. It requires organizational commitment for sure. The organization needs to understand the value that the lack of security posture, the firewall rule sprawl, the lack of understanding of applications, the lack of shared ownership between that. One of the interesting things, I've been in several conversations with customers where I asked the application owner and the security team says, who owns the rule? And they both do this, right? So in essence, nobody owns a rule, right? Which fundamentally means that has to be positioned from top down to say, this is important. This has to do with our security posture, et cetera. It's not an easy thing. Like I said, that would be the biggest flaw to something like this. But there's many side benefits, side effects, et cetera, for having this data. And there's just so much more metadata to gather on applications that just the metadata alone is worth a lot.
Oh, we got one more. We got a minute left.
This is first NANOG, first question from Brian Davenport at Team Condry. I was just curious, you kind of mentioned it's top down, so where do you see the resistance come in an organization typically? Is it the firewall owners or the network people or the application? Like, where do you most see the resistance?
I mean, listen, the firewall rule problem has been a data nightmare since its inception. It is basically everyone throwing the data over the fence and saying, deal with the security team, right? So why do the application owners want to change, right? And so that the application owners, the local IT, the people putting the requests don't want to necessarily change that because to them, it's, maybe it's slow, but why should they have ownership? So that's pretty much uniformly where I see it.
All right. 23 seconds to spare.
Awesome.
Round of applause for Ken, please.
Thanks.